Today we are going to be learning about the properties of numbers and the distributive property. These are sections 2.1 and 2.2 in the textbook. First, let's do a little mental math warm-up. Here are some of the problems. The answer to number 1 should be 27. Number 2 is also 27. Number 3 is 180. And number 4 is 180 as well. Now let's see why. First, we're going to look at the commutative properties of addition and multiplication. The commutative property states, the order of the values does not change the sum or the product. So, if we look at an arithmetic problem, we can see that 7 plus 3 also equals 3 plus 7. The same is true for algebra problems, so a plus b is equal to b plus a. The commutative property also works for multiplication. We can see that 2 times 4 is equal to 4 times 2, and a times b is equal to b times a. Example 1 is a visual representation of the commutative property. In the first bag, there are originally 16 green marbles. Then, 3 orange marbles are added in, making 19 total. In the second bag, there are 3 orange marbles originally. Then, 16 green marbles are added in, again making 19 total in the bag. As you can see, it does not matter which marbles originally start in the bag. In the end, there are still 19 total. Now we will look at the associative property of addition and multiplication. The associative property states, the grouping of the values does not change the sum or the product. The associative property basically says that as long as the sign is the same, where the parentheses go does not matter. In the example of 2 plus 7 plus 3, the parentheses can go around the 2 and the 7, or the 7 and the 3, and the answer will be the same. Again, the same is true in an algebraic equation. A plus b plus c can be written as a plus b plus c, or a plus b plus c. Again, we can apply this to multiplication as well. Therefore, 9 times 4 times 5 is the same as 9 times 4 times 5. Just as a times b times c can be rewritten as a times b times c. Okay, now let's say it's a Friday night and you and some friends are going to the movies. At the movie theater, you buy an adult ticket, a small popcorn, and a small drink. First, using the table, find the total cost of your trips to the movies. Your total cost should be $9. Without even realizing it, you probably used one of the properties we learned to come to that answer. So which properties did you use? You must have used the associative property. Maybe first, you added together the price of the ticket and the price of the popcorn, and then decided to add in a price of the drink. Or maybe you first added the price of the popcorn and the drink, and then added in the price of the ticket. Either way, you should have gotten a total of $9. In example 2, we are going to use mental math and the properties to solve the following problem. 100 times 3 times 2. First, we can use the commutative property to show that we can reorder the terms to make the problem 100 times 2 times 3. Next, we'll use the associative property to put parentheses around the easier of the terms to multiply. In this case, that would be 2 times 3. Then, we will multiply within the parentheses, getting 100 times 6. Lastly, we will solve 100 times 6 to get a final answer of 600. The next property we will look at is the identity property of addition. The identity property states, the sum of any number and 0 is the original number. For example, 7 plus 0 is equal to 7, and 0 plus x is equal to x. Next, the identity property of multiplication states, The product of any number and 1 is the original number. So 15 times 1 is equal to 15, just as 1 times b is equal to b. For example 3, you're going to name each property shown. I'll give you a second to work these out. For the first one, 3 times 4 is equal to 4 times 3 is the commutative property of multiplication. For number 2, z times 1 is equal to z is the identity property of multiplication. Okay, now this next one's a little different. Instead of numbers or variables, we have shapes. However, the same properties can apply. So square plus star is equal to star plus square. This is the commutative property of addition. And number 4, 5 times parentheses x times y is equal to parentheses 5x times y. That is the associative property of multiplication. Now we will look at the distributive property. The distributive property states, to multiply a sum or difference, multiply each number within the parentheses by the number outside the parentheses. As a numerical example, 3 times 2 plus 6 can be rewritten as 3 times 2 plus 3 times 6. Or 2 minus 6 times 3 can be equal to 2 times 3 minus 6 times 3. Algebraically, the same can be true. We can use the distributive property to rewrite a times b plus c as a times b plus a times c. Or we can change b minus c times a into b times a minus c times a. One way to show how to distribute a term is to use arrows. Use arrows to show that you distribute every outside term to each individual inside term. In this case, you draw an arrow from A to both B and C. Mainly the arrows will just help you to remember to distribute every outside term to each and every inside term. In example 4, we are going to use the distributive property to find 20 times 102 mentally. The first step is to break up 102 into 100 plus 2. Then we will use the distributive property to distribute 20 to 100 and to 2. Now we have 20 times 100 plus 20 times 2. From there we can multiply to get 2,000 plus 40. And then we can add to get a final answer of 2,040. In example 5, you have 3 friends and want to give each friend 6 cupcakes, 5 cookies, and 4 brownies. How many baked goods will you have altogether? We can use the distributive property to distribute the 3 to the 6, 5, and 4. So we'd have a total of 3 times 6 plus 3 times 5 plus 3 times 4. When you multiply that out, you get 18 plus 15 plus 12, which equals 45 baked goods. We can also use models to represent this problem. Here the circles represent cookies, the squares brownies, and the diamonds are cupcakes. As you can see, each friend was given the proper amount of baked goods. Then we can simply count the total number of baked goods and come up with an answer of 45. Here are some practice problems for you to try. Number 1. 3 times 6 plus 7 is equal to 39. 4 times 22 plus 3 is equal to 100. 6 times b plus 5 is equal to 6b plus 30. 9 times 2h minus 1 is equal to 18h minus 9. 3 times 5 minus 3w is equal to 15 minus 9w. And then for number 6, suppose your friend wrote 7 times 2m plus t is equal to 14m plus t. What what error did your friend make? And then what is the correct answer? As we can see here, he or she forgot to distribute the 7 to the variable t. So the correct answer should be 14m plus 7t. And that is the end of the lesson. All of the pictures used in this presentation are from the following websites: all definitions and examples were used from the Prentice Hall Pre-Algebra Teachers Edition textbook or created by Michael Bader, student of Central Michigan University.